Hello. In this session, I am going to start introducing some tools that will be very useful when it's time to do budget analysis. And when we think about budget analysis, in this particular case, we are going to be thinking about the expenditure side of the budget equation and the revenue side of the budget equation. So what I will do today is just introduce basic tools that will allow you to convert data into a meaningful story. And that budget story is something that you want to tell decision makers that are trying to put together a budget document for the next fiscal year. So the idea that I have for this session is we are going to start by talking about a trend. What is a trend? Well, that is fairly simple. I can just tell you that a trend is any measure that you are going to analyze over time. When we think about this particular context in budget analysis, we think about fiscal years, and then we think about the particular measure that we're analyzing here. Here, let me start with a measure in dollars. So what we have is measures over time, and these measures over time will allow us to tell that story. Now, what we have today is different measures that we can use. These measures are the following. We can start talking about a measure that is called a percentage change. I'm sure that many of you have used this before, not necessarily in the context of budgeting, but that's something that we're going to do right now. We can also talk about proportions. We can talk about a very important distinction that you need to understand, which is the difference between nominal versus constant units. And we are going to be talking about that as constant and nominal dollars. And finally, we're going to be talking about per capita terms. Now, we don't need to have a high level of complexity in this class. But if you understand the basics, and these are very basic measures, that will give you plenty of material to start developing a credible and very interesting story. So we are going to have simple explanations of these measures in this class. In a different session, I will tell you how to use this in Excel, and then you are going to be using this kind of information to write a budget memorandum with data that I could give you or data that you can easily obtain because a lot of this information will be public for many levels of government. So we start with the first measure. Let's start with a percentage change. To make this example easy to understand, let's start with something very simple. Imagine that you have two fiscal years, fiscal year 1 and fiscal year 2. You are going to have expenditures that are worth 100 in fiscal year 1 and 120 in fiscal year 2. When you start thinking about budgeting, you start thinking that these numbers are going to be representing different line items in a budget. And one example of a line item could be, for example, salaries. Another one could be police cars. Another one could be uniforms, etc. So you could have a list of line items here, and each of these line items will be associated with a certain dollar amount. Now, someone is asking you to provide an explanation by using a trend, but they don't want a trend that is using these amounts. They want a trend that is showing percentage changes. So the question is, how can you convert these numbers into a percentage change? In other words, what we want to know is what is the percentage change between fiscal year 1 and fiscal year 2 for this particular line item. So the formula that a lot of times we use directly from Excel or from other software by clicking into an icon is the formula that I'm going to explain to you right now. I want you to think about this as a formula where you have that the percentage change that you need can be obtained if you have the later year and then you subtract the earlier year, then you are going to divide by the earlier year, and then once you do that, you're going to obtain a number, and you are going to multiply that number times 100. Write down this formula. Let's consider that as a generic formula. Now, the very same formula could be expressed by using these terms in here. In that case, the very same formula would be fiscal year 2 minus fiscal year 1. That means the later year minus the earlier year divided by what would be the earlier year in here. It would be fiscal year 1. Then all of this will give you a number, and you are going to multiply that number times 100. This formula, which is exactly the same as this generic formula, will give you the percentage change from 100 to 120. That will give you the percentage change in this particular line item between fiscal year 1 and fiscal year 2. If we are going to calculate the numbers in here to obtain the percentage change, well, that will be very straightforward at this point. We're just going to apply this formula here. When we apply the formula, and I will do this in orange, what we're going to have is the following. 120 minus 100 divided by 100. Fiscal year 2 minus fiscal year 1 divided by fiscal year 1, and the number that we obtain times 100. Now, at this point, you can present your numbers in two ways. You could present this number as a decimal number, because if you do the calculations, you're going to notice that this calculation, the one within the parentheses, is going to give you a 0.2. You could tell a story by using 0.2. Sometimes we automatically see this as 20%, but sometimes people do not see that clearly. So when you multiply this number times 100, that means you include this, then that is going to give you 20, and then you are going to express that as a percentage. So the result is 20%. The story that you could tell in this simple example would be, for this particular line item that is going to be called salaries, we have an amount of $100 in terms of expenditures in fiscal year 1, and then in fiscal year 2, expenditures went up to 120. This change can be represented as a 20% increase between fiscal year 1 and fiscal year 2. As you can see, this is very simple. You have done this in the past, it's just that you haven't followed this rationale probably, because sometimes we just go to Excel, we enter the data, and we obtain the numbers. It was important for me to show you how we obtain this particular number. So later, we're going to start thinking about the story that we can tell with this. That being said, we can move to the second explanation. The second tool is going to be called a proportion. We are going to be talking about proportions in this class in the context of public budgeting. And when we do that, we are going to have something that you have also seen in Excel, I am sure, very often. And that is going to be a pie chart. So a pie chart is a representation of a proportion. What we are going to do right now is just another simple example that will allow us to understand what that number means and how can we make a connection with the budget story that we're trying to tell. So let us assume that someone is asking us the following question. What are the main categories of spending in a particular agency? When we think about the main categories of spending, we can start thinking about a pie chart. This is what you have seen in Excel. You enter some data, and then the pie chart is going to start giving you different proportions. In this case, we could make a point that in agency A, the spending is distributed in three, let's call it large expenditure categories. We are interested in this particular category. We could think about this one as the proportion of salaries compared to the whole, compared to the total. How do we obtain this number? Well, we start with a very simple formula. If we want to know the proportion of something compared to the total, we are going to have a certain dollar figure that is going to represent this. We are going to divide that by the dollar figure that represents the whole, the total. And once we have that, we are going to multiply times 100. How are we going to do that? Let's work with an example. This will clarify a lot of the questions that you may have at this point. Let us assume that in a particular fiscal year, let me call it fiscal year 5, we have a spending category that is called salaries. We have another spending category that is called supplies. Then we have one that is called services. And then we have another one that is called, let me put CI, which is going to stand for capital improvements. Think about these four categories as 4 line items. Each of these line items is going to have a number that is represented in dollars. So we're going to have $75,603 for salaries. We're going to have $883 in supplies, $10,577 in services, and in this particular fiscal year, we don't have any expenditures recorded for capital improvements. If we add these 4 line items, we are going to have that total expenditures in this particular fiscal year are going to be $87,063. Once they give us that scenario, they're telling us we want to know, for example, the proportion of salaries compared to the total. Well, once you have this information, it looks very straightforward. If they want to know the proportion of salaries to the total, what we need to do is just estimate the proportion here. So what we want to know is what is the proportion of $75,603 compared to $87,063, which is the total. I want you to use the formula, the simple formula that I explained before. It's just what is the proportion of this in this times 100. Do it and see if you can obtain a number that is 86.84. If you obtain that number, that means that you divided this number by this number and you multiply times 100. Then you're going to see that the proportion that you want is 86%. How do you interpret this number? Well, in a pie chart, probably it's not going to look exactly like this because the proportion is larger, but the proportion of salaries in the total for this particular agency would be 86.84%. When you do this kind of analysis in 2 periods of time, for example, comparing fiscal year 5 with fiscal year 10, then you could see how this proportion is going to change over time. And again, the important thing here is to know the story that you can tell by using this kind of information. The next step will be to think about nominal versus constant dollars. And this is something that is very important because it is not the same thing to tell a story with nominal numbers than to tell a story with constant numbers. So I am going to introduce this simple tool, and then we are going to be talking about some concepts that will allow you to understand why or when to use one and when to use the other one. You can think about it like this. We are going to be talking about measures that are in nominal terms versus real terms. Sometimes to the nominal, we like to call them current dollars, and to the real, we like to call them constant dollars. What is the difference between one and the other one? Well, imagine that you have a dollar bill with you. That dollar bill is a piece of paper. It's just a piece of paper that is green, it has a number 1, and it has a picture. So the value of that dollar today is $1. The value of that dollar in the future will change, and it will change, for example, because of inflation. When you have high inflation, next year, for example, you still have that piece of paper that you call a dollar. But now the value of that dollar is different. So we need to start making a distinction between nominal and real so that we can account for the impact that this effect that is called inflation is going to have in that dollar. Let me explain this with a very simple example, and then I'm going to introduce a formula to calculate it. Think about fiscal year 1 and fiscal year 2. In fiscal year 1, let's assume that you have a line item that is worth $5,000. In fiscal year 2, you're going to have that the same line item is going to be worth, or is going to represent $6,500. These two measures are going to be in what we're going to call current dollars. What we want to know is what is going to be the value of these two measures in constant dollars. So we need to take into account the impact of inflation. We are going to use a very simple formula to do that. To convert from nominal to real, you are going to just do a very simple procedure, that is, you are going to consider the expenditure that is measured in nominal dollars. You are going to divide that number by one measure that in this class we are going to be using that is called the consumer price index. There are different measures that could be used in the denominator, but right now I just want you to focus on this one. Something that we are going to be calling consumer price index, that I'm going to explain later, will be the denominator here. Once you do this, you are going to obtain a number, and you are going to multiply times 100. When you use this formula, you will be able to convert something from current to constant, or the same thing, from nominal to real dollars. Here's an example. If you want to know the value of 66,500, which is in current dollars, you want to know the value in constant dollars, let us assume that you have a consumer price index that for fiscal year 1 will be 100, and for fiscal year 2 will be 110. Something that I can tell you right now is that this is an index that reflects the change in the prices of a certain basket of goods. And that is going to be a measure of inflation. So in this case, I can tell you that when you have that the index, which is the consumer price index, went from 100 to 110, what we are implying here is that there was an inflation of 10% between fiscal year 1 and fiscal year 2. That means that the value of $6,500 measured in constant dollars will not be the same. So what we want to know is what happens when we convert or when we represent this line item not in nominal dollars, because we have nominal dollars in here, but in real dollars. That means that we need to take into account this inflation of 10%. If we use this simple formula, we know that for this amount, we would have first the amount in nominal dollars divided by the consumer price index for fiscal year 2, which is going to be 110, times 100. When we divide this by this, we're going to have a value of 59.09, which would be difficult to interpret. But when we multiply times 100, we are going to have that the result will be 5,909. What is the interpretation? The real value of $6,500 is $5,909. Why? Because there was an inflation of 10% that is represented by this change in the consumer price index. The decision will be, you need to decide whether you want to represent something in nominal dollars or if you want to represent it in real dollars. And that is usually depending on the story that you want to tell. We are going to go back to these concepts later, but right now I want you to think about this formula and to see that it's very difficult, very easy to go from nominal to real. What we need to know is when to use one and when to use the other one. And the key is, what is the treatment that we want to give to inflation? That being said, we can go to the final measure of this session. And that is going to be a very simple measure that is called a per capita measure. We can measure things in per capita terms, many things. So we can think about this in the context of our expenditures, but we can also think about per capita measures in many other contexts, not necessarily related to budgeting. So here's how the story goes. When we measure something in per capita terms, the only thing that we are claiming is that that measure is going to be compared by using the population as a reference point. So any measure that you want to represent in per capita terms, let me call it anything that is divided by a measure of population will be giving you a certain number in per capita terms. Again, this is easy to estimate, but the important thing is to know what is the story that you want to tell. In the context of budgeting, we could use this, for example, to analyze expenditures over time. So what we want to know, for example, is think about expenditures in police. So you have a certain amount for each fiscal year that has been spent in police services. So you want to know the importance of these terms in terms of the population. So you want to know how much has the government been spending in police services in per capita terms. So you're going to have that measure, think about 1 million, 5 million, etc., divided by population, and then you're going to have that measure per capita. In that case, when I go back to this simple graph and I tell you that you could do this over time, you are going to have a certain amount in dollars, in this case, dollars per capita, and you're going to have a trend. Let us assume, so that we don't spend a lot of time doing calculations, that the numbers that we are obtaining in 3 units of time, 3 different fiscal years, will be, let's say, 100, 150, and 200. This is telling us in per capita terms, meaning per person, the city or the government that we're analyzing has been spending $100 or spent $100 in fiscal year 1, $150 per capita in fiscal year 2, and $200 per capita in fiscal year 3. What story can you tell when you are interested in analyzing police expenditure in per capita terms? The story that you could tell, for example, is how much each of the taxpayers living in that particular jurisdiction is spending on police services on average. So in this case, we could say, the numbers that we obtain are telling us that in per capita terms, each resident in this jurisdiction has been spending an increasing amount of taxpayers' dollars, of tax money, in police services. In some cases, this would be good, because you would expect that if there's an increase in police services, well, that's something that you want because that gives you public safety. But when you don't see the change as a taxpayer and you still have crime, then you would say, why are we spending more money in per capita terms in police if we don't see the benefits or the results? Well, maybe there are salary increases in the police. And when they increase their salary, then you are not seeing an expansion in police services. You just see that they are receiving more money. And that is going to be reflected in this per capita measure. Now, I want you to think about one of the, I wouldn't call it a limitation, but one of the things that you need to keep in mind in here. When we divide by population, the question is, what is the measure of population that we're going to use? Think about San Diego, for example. When you are doing this for the city of San Diego, I would tell you, well, we have different ways to measure population. And then we could tell that population could be the number of residents, the number of legal residents. We could also talk about people that are 18 years old or older. And this is a very important one. Why? Because, look, people that are less than 18 years old, should they be counted in this measure for police services? I mean, they're not paying any taxes. Most of the time, they don't pay any taxes. Sometimes they start working when they're 17. But, think about a kid. A kid maybe should not be counted here. But if you consider residents as your population measure, then kids are going to be part of this measure. So what? Well, depending on the number that you choose for population is the number that you are going to get in here. And depending on the numbers that you have in here is the story that you are going to tell. So when you start comparing these numbers with something else, it could make a difference if you use residents or just people that are 18 years old or older. In some cases, you might find that there's a problem. But at the moment that you change your population measure, maybe you're going to find that there's actually no problem. So it all depends on the numbers that you choose. And that is something that I want all my students to be aware of, because when someone is reading a budget memorandum or any document that you present, there's going to be an appendix. And in that appendix, you are going to discuss the methods that you use for a particular measure. Now, someone could only read the budget memorandum. In that case, they will go along with the story that you're trying to tell them. But if that person, think about a decision maker, has an advisor, then the advisor will immediately go to the appendix to see what's happening here. And then they could challenge your whole analysis based on these kind of measures. So this is something that is usually hidden. But someone like you, after I give you this class, should be able to identify and question if it is something that, in your opinion, is changing the analysis. I introduce the 4 measures that we're going to be using in this class briefly. Something that I can tell you is that even if the examples that I gave you are on the expenditure side of the budget equation, you could do the same thing or use the same kind of analysis to analyze the revenue side of the budget equation. This is something that at this point you should know. When we think about analyzing the expenditure history or the revenue history of a local government, what you will be doing is analyzing data by using measures tools like this to obtain numbers that you will represent over time. That means a trend. And that trend is going to give you a meaningful story about something that you are observing in the city or government that you are analyzing. So now that I introduced the topic, we are going to start discussing this in the context of Excel. And that will be the subject of the next session. Thank you very much for your attention.